Hello everybody, and welcome back to another Universe Sandbox video. Here we are, back in the Kerbal system, because, yeah, as of recently, I guess due to, like, Artemis 2 and just, like, a resurgence in KSP players, my old video on if the Kerbal system is stable has gotten a lot of views, so thank you for that. But, I also got a lot of comments mentioning, like, a lot of other things, and one that really stood out to me was Kerbin. So yeah, as you can see, we have Kerbin here. We have our updated orbits here, or Minimus orbits retrograde. I don't know, for some reason when I loaded this up, Gilly got destroyed. So rip Gilly. But yeah, Kerbin here. Is Kerbin actually habitable? Or like, you know, I mean, obviously it's habitable, but what would it be like living on Kerbin? So as we can see, if we take a look at its surface, it's got pretty average temperatures, 20 degrees C. Although it's like 20 degrees C everywhere. Let's set this to what I understand. So that's like 70 degrees pretty much everywhere, with some cold spots, I guess, up on the mountains. So yeah, very wild temperature fluctuations, which, you know, in real life would probably cause a lot of extreme weather. So we do have that. Yeah, but one thing that was brought up is that Kerbin does not have any tilt. As you can see, it is right on with Kerbal. It is vertical up and down. There is no axial tilt. So not only will that get rid of seasons, but it will make the transitions between, like, regular. As you can see, it's really just hot everywhere. Like, I mean, it's 69.2 degrees isn't that hot, but also we're dealing with a smaller star here. So, you know, it's a decently warm everywhere, with a couple cold spots up in the mountains. And obviously, of course, you can't forget the density of Kerbin is 58.5 grams per centimeter cubed, which is denser than the densest material that we know. I mean, not quite, you know, neutron star dense, but, you know, it's getting up there with how packed everything is. And that's just true for the whole Kerbal system. Because, yeah, for instance, this is Earth. Just a comparison, that's the size of Earth compared to Kerbin. If we actually go, this is actually a really fun fact. If we go to Joule, and you can see Joule and all its lovely moons that are now stable, and we go ahead and grab the Earth, look, they could be like buddies. Obviously, Joule's a little bit smaller, but they could be real buddies. They could be big old buddy old pals. So, yeah, that's just kind of something interesting. Actually, I think, hold on, let's deselect Earth. What about, I want to select Venus. Because Venus is slightly smaller than Earth. Oh, there you go, Venus. Oh, there we go, that's a bit of a closer approximation. Venus is still a little bit bigger than Joule, but yeah, it's a closer approximation. Even Mercury is, like, bigger than most of the other planets in this. Even Pluto's bigger than Lathe. So yeah. Yeah, obviously, Kerbal Space Program is really small, which is why, you know, it's so easy to navigate. But yeah, let's see what would happen. Because obviously we can just look at this and be like, that doesn't look quite right. This temperature, not great. Average temperature is 56.5 degrees Fahrenheit. I mean, just for comparison, let's compare this to Earth. So I'm going to leave this here. So remember what that looked like there. Comparing this to Earth, the Earth's surface. As you can see, the temperature bands are a lot more... Yeah, we have like a bigger cold band at the bottom and at the top, where Kerbin we didn't have any of that, and we got a bit more of an even heat distribution throughout the center, whereas it was just hot everywhere. Which, I'm not like a weather person, I don't really know like what that would do to the weather, but the fact that we had like those mountains and they were like really cold at the top of the mountains makes me think that the weather would be pretty messed up. And yeah, obviously Earth is a whole lot warmer than Kerbin. Kerbin's quite cold, actually, compared to Earth, which probably might be just because the sun's smaller, or, you know, the planet's smaller, therefore it can't hold as much heat. Not really sure what the science behind that is. But yeah, as you can see, this is what Earth looks like. Same surface gravity. Escape velocity is different due to size. So anyway, let's head back to Kerbal system. Back to Kerbin. Okay, it already wants, it's like, yes, let's fix Kerbin. Let's fix Kerbin. The transform tool. Why is that open? I don't need the transform tool open. It's like, yes, we're gonna fix Kerbin. Yes, give me a second. Give me a second, game. We'll fix it. So yeah, again, looking at this. Got some very cold spots up on these mountains. And yeah, actually, if you look at that, look at the life likelihood. 1.59%. Just because of how crazy I guess the temperature gradients are. Or maybe some other reasons like the density. So it's amazing that the Kerbals exist at all. At least based on this. Yeah, so there you go. So the surface gravity is the same, but escape velocity is 3.43 kilometers per second, which is, you know, pretty much what it is in Kerbal Space Program. So very cool. So yeah, let's give Kerbin a tilt. Let's tilt it. Let's give Kerbin some seasons, and let's see if this changes anything. So we're gonna tilt it by probably about that much. So give it a bit of an axial tilt. So there we go. There's our axial tilt. Yeah, let's see what happens here. Minmus is getting evaporated. I think that's relatively normal. As you can see, we are starting to get a bit more of a cold band at the bottom. So over time, the temperatures should probably even themselves out. So let's just give it a lot of years. A lot of going through the seasons. And yeah, look, the yellow band's starting to increase. And we're starting to get a more normal temperature gradient across the planet. The average temperature has spiked up a ton, actually, which is surprising. It seems like it's melting some of the... That's interesting. So I guess a lot more of the heat is getting focused into the center, so the average temperature is actually going up. So it's making the planet warmer. Wow, that made the planet like 100 degrees Fahrenheit at the in the normal region, 43 at the poles. Average temperature is 21.6. Okay, that's around the same as Earth, I think. So yeah, we have a tropics now, basically. We have a very warm tropics. The kind of habitable areas would be like down here. This mountain here has gotten really warm. I think it's just because we've melted so much of the ice in the center. But yeah, look how much the bands have gone. I don't know how much of a tilt we gave it. If we gave it too much of a tilt, I don't think so. I think that was pretty much perfect. Let's check on the life likelihood. I think Earth similarity went down. I can't remember what this was. It seems to be about the same. I think Earth similarity was like 50-something. Yeah, I mean, it just needs more time to settle everything out. Melt this ice in the middle and... Minimum temperature, maximum temperature. I think we're roughly at the equilibrium. I mean, what will be the equilibrium temperature? 44.2. Goodness. So do we get like a runaway greenhouse effect a little bit by doing the tilt? Water, hydrogen. There's no CO2 in the atmosphere. Yeah, there's no CO2 in the atmosphere. It's just hydrogen and water. There's no oxygen in the atmosphere. Probably because this was made before this system actually was invented. Maybe that's why the Earth similarity is so low. Yeah, because this was added a bit recently. So let's see. Earth, atmosphere mass. We'll add like 0.2. We'll add some oxygen for you. We'll give Kerbin some oxygen. I guess hydrogen's fine, 0.2. Maybe give it some... I mean, the fact that the atmosphere is 0.2% hydrogen is a bit concerning. We'll give it some nitrogen, though, 0.6. So we'll see if that does anything to the surface. Oh yeah, I think that's made everything a bit colder. Less of a greenhouse effect. I guess hydrogen must be a really good greenhouse gas or something. Yeah, now we're pretty stabled out. Average temperature is fine. We do have some hot spots, some mountains, and cold area, very cold areas. That honestly seems like a fine temperature band. That's what we got for Earth similarity. Oh, it's gone down. Life likelihood has gone down. Okay. What's the overall atmosphere mass? I think I saw that somewhere. I forget where it was. Was it the surface that this is located? Yeah, atmosphere mass. Okay, so we're roughly at 1 Earth atmosphere. I think we need to add... Do we need to add anything? Minimum temperature? I mean, that minimum temperature is really cold. I think what I'll do is I will stabilize the temperature. Just speed up the temperature fluctuations. Seems like the South Pole got really cold, actually. Oh, but the life likelihood went up. It's back to 1.61. Earth similarity has gone down, though. Maybe we'll get rid of some of the hydrogen. We don't need this much hydrogen. Get the hydrogen out of the atmosphere. We don't want hydrogen in our atmosphere. We'll get like a little bit. So we have like nitrogen, we have oxygen, Get a bit of CO2, but like 0, 2. Just like what Earth is. I mean, I don't know if Kerbals produce CO2. They might be plants. Although plants actually do perform CO2. They do make CO2. People don't realize this, but plants only make oxygen when they have sunlight. At night, they produce CO2. They do cellular respiration, which is the same thing we do when there's no sun. Fun fact about plants that you might not have known. Yeah, they produce CO2 at night, and then in the morning when the sun comes up, that's when they do their photosynthesis. Because yeah, obviously photosynthesis don't work when there's no sun. So let's just give this a lot of time and see where the temperatures settle. Yeah, there we go. We're warming up a little bit in kind of the middle regions. Things are looking a bit more realistic here. The greenhouse effect is insane. Oh, the surface pressure is 87 atmospheres. That might be why. Yeah, let's crank that down to like, 1 atmosphere. Alright, now let's see what happens. There we go. That's doing something. Oh, the surface pressure is rising again. I guess because the planet's so small that a small amount of mass results in a really high surface pressure. So that's another thing too, because it's so dense, the atmospheric surface pressure is super high with very little atmosphere mass. We don't even have like a Mars atmosphere. Or we have 7 Mars atmospheres. What would be a good comparison? A moon atmosphere, no. Yeah, no, we just have Earth mass and Mars mass. But yeah, we're at 0.03 of an Earth mass, 7 Mars atmospheres, and the surface pressure is 4 times Earth atmosphere, just because of how dense it is. But but our changes we made the life likelihood go down even lower. So yeah, obviously dense planet, not great, not great. Yeah, all this stuff went down to like next to no amounts. I mean, we've definitely created a more even temperature band by tilting the planet. The atmosphere just seems to be very tricky to get right because of how dense the planet is. Again, we're talking about 58.5 grams per centimeter cubed of density. And the amount of matter is very little. So it's a very dense, very dense. See if that does anything to help us. The temperatures look like they're a bit more reasonable. Although I'm looking at Celsius, not Fahrenheit. Gosh, 162 Fahrenheit would be horrible to live. That's pretty much all the equator is 162. Yeah, it's way too hot. We've made the planet way too hot. I think I need to remove some of the greenhouse gases. Yeah, let's just ditch the carbon dioxide. No more CO2 for you. Water is also a greenhouse gas, but yeah, we're just going to ditch the CO2. I think that was causing a lot of problems. Oh, that might just be the water now that's causing all this greenhouse effect. Maybe we can get rid of a little bit of the water. That's half maybe the amount of water. Equilibrium temperature is now 42. Okay, I think that might have helped, halving the water level. I mean, as we remove the water, more of it just evaporates into the atmosphere. So it might not be possible to get rid of all the water. Otherwise there'd be no water. Yeah, very tricky to get right. We've gotten the Earth simulator back up, I think. But the life likelihood is still next to nothing. This would be half the water again. Let's maybe decrease. Let's just cool it down a little bit. Average temperature, let's bump that down to 20. And there we go, now that looks a bit better. Earth similarity went back up. Life likelihood is just staying low. Also, yeah, how long is a Kerbin day? Isn't a Kerbin day only 6 hours? That might also be something. Because, yeah, 6-hour days just don't give enough time for really, like, temperature to stabilize and everything. Because I think that's how a Kerbin day is. Motion, yeah, there we go. Yeah, 0.2 days is our rotational period. 6 hours. So I guess let's change this to a day. Let's see how that affects things. So now rotational period is 1 day. Now the planet won't be spinning so fast, so maybe that will actually do something. Let's see if that actually does something. I mean, the year, we might also have just an issue with the year. Let's see, how long is an orbit? Orbital period takes 17 days. A year on Kerbal, a year on Kerbin, not on Kerbal, that's the sun. A year on Kerbin is 17 days. I don't know how many Kerbin days that is, because that's 6 hours. I guess we can do the math. So 17 times 24 to get 24 hours. So 408 hours per year. Then we divide that by 6 to get Kerbin days. 68 Kerbin days, roughly. I didn't carry the 0.4, but yeah, 68 Kerbin days. We can run that up to 69. Nice. There we go. That's a bit more reasonable. 67 degrees C, 68 at the equator. Negative as we kind of get closer to the poles, and then bitter cold on the North and South Pole, which is pretty much what Earth is like. 39.5%, 0.141 life likelihood. Yeah, I don't know if we can get the life likelihood that high, just because of how everything going against us, the density, the everything. But it seems like reducing the day has... I feel like that's affected the temperature. I mean, it could have been some of this stuff we did here, but yeah. I mean, the Kerbals just, they're built different, I guess. Definitely would be not ideal to live on, you know, Kerbin. Let's just go back to what we had before. So yeah, this is what we started with. Splotches of cold on the tops of mountains, pretty much warm everywhere except for right near the poles. Honestly, the temperature here is not that bad. 21 degrees C, not that bad. Probably because we have all the ice and the albedo is keeping the planet cool. But, you know, weather patterns from the cold air mixing with the warm air, you're gonna get lots of storms. Versus what happens when we just add a little bit of tilt, just a little bit of tilt, we start to get a lot more warm in the center because we melt that ice. A lot more of the temperature is focused in the center, so we melt the ice on the tops of these mountains. A lot more temperature. I mean, just props to the guy who made this system. I don't know if he was following, like, the Kerbal system exactly, or if he was really just trying to... I mean, I guess you would do the parameters and then you would tweak the intensity of Kerbal to make it habitable, if I were to guess. But yeah, I mean, doing this, actually adding the tilt, does make it a lot warmer in the center. It would probably help with the weather patterns. Like, you wouldn't get so much intense weather, but honestly, pretty fine as is. Just goes to show how much goes into the planets, and yeah, I mean, if we check other things, there's other things that aren't quite right, like the atmospheric density, or the atmospheric pressure being 24 atmospheres. Well, that ain't quite right, with it only being 0.2 Earth atmospheres. 44 Mars atmospheres. But I mean, it's fine. But that would also, you know, explains why the Earth similarity isn't 100% and the life likelihood is only 1%. So, anyway, I think I learned something. And if you guys did, please be sure to leave a like. And yeah, let me know if there's anything else you want to see me do in the Kerbal system. Maybe we can try terraforming Duna. That could be fun. I did a whole series on terraforming Mars. Could we terraform Duna? Or would we have very similar issues to what we had with, you know, Kerbin? I don't know. Be interesting. Anyways, see you guys then. Bye!